All right, this next lecture, week 3, is rather long. We have looked now at the built-in data structures for Python, namely lists, tuples, sets, and dicts. We're going to take a look now at functions that we can use for constructing these things from so-called iterables. We're also going to take a look at comprehension notation that we can use in Python to build lists, sets, and dictionaries in a convenient and compact notation. Things go wrong while programs are running, and some of these things are severe enough that they do what's called raising exceptions. These indicate things like dividing by 0, or trying to access an element that's out of bounds in a list, and these kinds of problems. We're going to take a look at how to capture these exceptions and resolve them in a way that doesn't cause your program to crash. One source of exceptions is user input. If you ask the user for their age and they type in a string, then very likely when you try to convert that string into an age, that conversion is going to fail because the input you were expecting was probably an integer or a floating point number. And so we're going to take a look at how to use exceptions to clean up user input and ask the user to try again if they've made a mistake the first time around. We're going to take a deeper look at defining and calling functions, including what are called variadic functions, that is, functions that take a varying number of arguments. We're going to see how we can store collections of related functions into modules that we can either import ourselves to reuse our own code in the future, or that we could make available to other users so that they can use the functions or classes, which we don't know about yet, that we have defined in our module. Okay, so all of that stuff is approximately the first half of this week's material. And the second half is an introduction to something called NumPy, which provides highly efficient n-dimensional arrays of numbers that we can interact with. Okay, full plate for this week. Onward ho. So you can create a tuple using a constructor function named tuple. Likewise, you can create a set using the set function. You can create a list using the list function. All of these construction functions take iterables as arguments. And we know that we have iterables like strings, lists, tuples. A set is also an iterable. A dictionary can be treated as an iterable in multiple ways. You can either iterate through the keys, or iterate through the values, or iterate through the items, the key-value pairs. In this example, we're creating a tuple called tup1 using the tuple constructor function. And our iterable is going to be a string. This is a test. So what the constructor function does is to go through this string and pull out of the string the one-character substrings that make up this string and build a tuple from those one-character substrings. So when we look at tup1, we see that it contains these one-character strings, THIS space, IS space, A space, and so forth. All right? So the length of this tuple, sorry, wrong language. The length of this tuple is 14. Well, a tuple is an iterable, so here in this next example, we're creating a set with a variable name s1 referring to the set, and we're creating that set from tup1. Now, a set is not going to allow duplicate values. We have multiple i's, multiple s's, multiple spaces, multiple t's. So all but one occurrence of these multiple values are going to be tossed out, and S1 contains this collection of values. Notice that these are not in any particular order, all right, E, A, I, S, T, H, and so on, just some apparently random order. If I wish, I can take this iterable and build a list from it. Okay, and the list is created in the same order that the print function, the internal print function displays, or technically the representation function, the repr function, displays the set to your shell. If I do want this list to be sorted, of course, I can sort a list using the sort method. And now I have these one-character substrings sorted in ASCII character set order. It turns out that in the ASCII character set, the space character is the first printable character in the ASCII character set. And then the lowercase letters come toward the end of the character set, actually. And I've got these in ascending ASCII order, A, E, H, I, S, T. Alrighty. Now, a dictionary also has a construction function, all right, dict for creating a dictionary, but a dictionary cannot be created from a simple one-dimensional iterable, because each item in a dictionary has to be a key-value pair. So if we create for ourselves an iterable over what are called two tuples, then we can use our conversion function, our construction function, to build a dictionary from that iterable on two tuples. All right, so as one example of an iterable on two tuples, I'm creating a set of two tuples containing, all right, the first tuple is going to be A with an associated value of 12. And the second tuple is going to be B with an associated integer value of 22. Okay, so when I call the dict function to build a dictionary from this set of two tuples, A will be a key with a value of 12. B will be a key with a value of 22. I don't actually know, when I create this set, what order those values are going to occur in. All right, now when I wrote these notes and created and displayed this set, the B came out first, followed by the A. In this instance, the A is coming out first, followed by the B. So when I build my dictionary D1 from set of two tuples, dict, not dice. All right, let's try that again. Dict. My dictionary has the key A first, and the associated value 12, and the key B second. Remember that in current versions of Python, starting with Python 3.7, the keys are guaranteed to be in the order in which they were created. Okay, so this is one way of creating an iterable on two tuples. I just manually typed in a set of tuples, and each of those tuples has two values in it. I was careful to make sure that the first item in each of the tuples was a hashable value, because the keys for dictionaries have to be hashable. And strings, integers, floats, bools are all hashable. Now, Another way of creating an iterable over pairs is to use a function called zip. And let me show you what the zip function does here. Let's remember our list, ls1. This thing has got 7 values in it. The length of ls1 is 7. And if I ask for well, let's do this. ls2 gets list from range of 7. Now, I can use the list constructor function to build a list from an iterable. Range is an iterable, so this list is going to have the sequence of values 0 through 6 in it. Okay, so now I have one list that contains 1-character strings, 7 of them, and I have another list that contains a sequence of integer values, 7 of those. If I zip the list together with that sequence of values, that will give me an iterable on 2 tuples. So let me do that. Let me now it's not very interesting if I just create the zip itself. Okay, so if I just say zip ls1 and ls2, what's going to happen here is that the first value of ls1, which is this space character, is matched up with the value 0 from ls2. Then the little a from ls1 is matched up with the 1. The little e from ls1 is matched up with the 2. But if I just create the zip and display it, I get something that's not very interesting. I get told, oh, great, this is a zip object. I have to use the zip in an iterable expression, in an expression requiring an iterable, in order for that zip to be of any use. So let me do this. Let me say for item in zip ls1, ls2. Forgot my colon. Print the item. There we go. So now we can see what the zip function is doing. It's creating these pairs, these tuples of values, space associated with 0, a with 1, e with 2, h with 3. Now, rather than creating this intermediate list called ls2, in the example on slide 4, I've just said range length ls1 to do it all in one shot. And so let's actually do this now. So I'm going to say D2 gets a dictionary constructed from zipping ls1 together with the range of integer values that I get by asking for the range of the length of ls1. Okay, the range of the length of ls1 is the same as the range of 7, which of course is going to be these values 0 through 6, and now, poof, my dictionary has been built from the same values that were shown when I looped through that zip object using a for loop. So the key the key space is mapped to 0, the key A is mapped to 1, the key little e is mapped to 2, h is mapped to 3, etc. All right, so that shows examples of how to use the named constructor functions, for building a tuple, a set, a list, or a dictionary from some appropriate iterable. Next, we're going to look at what are called comprehensions. And a comprehension is a compact way of building a list or a set or a tuple. And a comprehension is the first thing that we've seen here that I'm going to identify as a Pythonic feature. Now, you will hear Python programmers describing various things about Python, as being Pythonic. That means that they are idioms or special ways of doing things in Python that are unusual or distinct or clever in comparison with other languages. Basically, you can think of Pythonic to mean cool, all right? So if you do something Pythonic, that's cool. Now, ideally, comprehensions give you a clear way of defining a list or a set or a dictionary, but it is possible to carry comprehensions to a sort of absurd degree and actually create very obscure code. Let's take a look at some hopefully straightforward examples. Let's suppose that I wanted a list of the 15 integer values, actually the 16 integer values from 0 through 15. Now, one clumsy way of doing that is to just manually type in the values. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13, 14, 15. I almost made it through without making a typing mistake, but I did make one typing mistake. Nevertheless, I do now have in this list named M20 the 16 values 0 through 15. What's the problem with this? Well, it wasn't much fun to do that typing. It's very easy to make mistakes. And how in the world does this help me if I want to create a list of 10,000 values? Clearly, I'm not going to manually type in a list of 10,000 values. So what's a more streamlined approach? Well, let's look at it this way. Let's say M20 is initially an empty list, and then let's use a loop for v in range 16 to generate those values 0 through 15. And now I can use my append method on M20 to append these successive values 0, 1, 2, 3 up through 15 to this empty list, so that when I'm done, I have my list of 16 values. This one is harder to make mistakes in. It's actually, I find, easier to make mistakes when you are typing a tedious long sequence of constant values. It's actually a little easier to write a loop that is brief. Also, it makes it possible for us to easily create lists of almost arbitrarily large size, because all we have to do is change the 16, to some other value like 2 billion or whatever the biggest list is that we can create given the memory that we have in our machine. Now, a comprehension basically takes this for loop and moves the for loop inside of the list instead of having the for loop contain the m20.append within it. Okay, so let's think about this. What we're trying to do here is we're trying to build a list. Building the list is the point. And yet, if we look at the code casually, it looks like a for loop is the point. Well, the list is really the point. The list is really the goal here. The for loop is just a means to an end to get us to our goal of creating a list. So the idea of the comprehension notation is, okay, let's indicate that we want to create a list, and to do that, let's put inside of the square brackets the for loop. So for each item in this list, I want to have the value of v for v in the range from 0 up to but not including 16. Okay, what I've typed here accomplishes exactly the same thing as what I typed up here. It's just a more concise notation, and it makes it more obvious that creating a list is the point of what I'm trying to do. When I hit the Enter key and look at M20, I see, yes, it is the same as the way I created the list before. So the general form of a list comprehension looks like this. We have some expression, and the values of this expression are going to be what make up the values within the list. Then we have a for loop that loops through one or more variables, taking on the values in some iterable. And the expression here can involve these variables being used to step through the for loop. Optionally, you're allowed to have additional for loops or if statements to conditionally include or exclude certain values from being brought into the list. Okay, so now let me show you some increasingly intricate examples of using this comprehension idea. Okay, now my first example was, let's comprehend a list where V is going to take on the values ranging from 0 up to 15. But I could be even simpler than that. I could say, let me create a list which is just 0 for V in range 8. Okay, so here I'm creating a short list. Every item in this list is going to be 0, and there are going to be 8 zeros in this list. Okay, so I can have 8 zeros. I can have 16 copies of V for V going from 0 up to 15. Or I can do a more complex expression, like in this next example, I'm saying for V squared for V in range 8. And that's going to give me the squares of 1 through 7. All right, 1, 4, 9, 16 up to 49. In this next example, rather than taking V to the second power, I'm dividing V by 2. Also, notice that I've added this optional if test. So for V in the range from 0 up to 9, okay, so V is going to take on the value 0, then 1, then 2, then 3, and so forth. If V mod 2 is 1, that is, if the value of V is odd, then in the list we're going to put V over 2. Okay, the first value in the range is 0. Well, 0 is not odd, so no value gets put into the list for 0. The next value in our loop is 1. 1 mod 2 is 1. That is an odd number. So I'm going to put 0.5, 1/2, into my list. The next value for V is 2, which is not odd, so nothing gets put in the list. The next value is 3, which is odd. 3 mod 2 is 1. So then I put 3/2 into the list. And the upshot is that the values in my lists here, the values in my list are going to be 1/2, 3/2, 5/2, 7/2, and 9/2. I'm going to have 5 values in M23. And let's confirm that that works the way I claim. So in my list, I'm going to put V over 2 for V in the range from 0 up to but not including 10, but only if V mod 2 is 1. That is, only if V is an odd number. Okay, and so now I have 5 values in M23 for the odd numbers, 1, 3, 5, 7, 9 over 2. All right, well, I don't need to limit myself to squares or halves. I can call arbitrary math functions. First I have to import the math module. So let me import math as m. And then I'll say m24 is m dot cosine of m dot pi times v over 4 for v in range 0 to 8. Okay, so if you've got some, trig background from math or engineering or physics or whatever, you may notice that what I'm computing here is the cosines of pi times 0 over 4, 1 over 4, 2 over 4, 3 over 4, and so on. So pi times 0, a quarter, a half, 3/4, 1, all the way around to 7/4. And the cosine of 0 is 1. All right, the cosine is the horizontal part of that vector in the unit circle, and so for 0, that's going to be 1. For 1/4, that's going to be the square root of 2. For 1/2 of pi, the value should be 0. However, because of round-off problems, because of pi not being exactly equal to the real pi, and because of cosine not being able to compute, exact arbitrarily many digit results, I do get a round-off error. It's kind of almost 0, but it's not exactly 0. All right, so those are my whoops. Those are my cosines of pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, and so forth. All right. Well, I can take things even, levels beyond that. In this example on slide 11, what I'm doing is creating a list of tuples. So my loop is modifying the value v to range from 0 up to 8. And for each value v from 0 up to 8, I'm computing v to the 1/3 power, v to the 1/2 power, v squared, and v cubed. And the parentheses around that indicates that that's going to be a tuple. So I'm creating here a list of tuples. All right, that's going to be too long for me to manually type in, so I'm going to cheat and copy and paste this thing. Okay, let me copy that and paste it in. All right, well, I didn't preserve the indentation very nicely, but fortunately for me, because I've got parentheses here, I can continue the statement and the indentation won't matter. Likewise, I've got square brackets around this whole thing. So I am going to get away with this despite the bogus indentation. And here is my M25. All right, so I have 0 to various powers, and I have 1 to various powers, and then I have 2 to the 1/3, the cube root of 2, the square root of 2, 2 squared, and 2 cubed. Then I've got the cube root of 3, the square root of 3, 3 squared, 3 cubed, and so on, all the way up to the cube root of 8, the square root of 8, 8 squared, and 8 cubed. Okay? So a list of 8 tuples, and each tuple contains 5 values. Okay, so that was a sequence of increasingly complicated list comprehensions. I just want to be crystal clear here that what makes these things comprehensions are that they're using the for loop. If you don't have a for loop, you're not doing a comprehension. That is, if I say this, if I say M123 gets list range 10, that does build a list, but it is not a comprehension because it does not have a for loop. M123 gets V for V in range 10. That is a comprehension. Okay, so just to be clear about the terminology now. Now the set can be comprehended in a way exactly like the list. The sole exception is that we need to put curly braces around the structure of the comprehension. So here I'm saying S20 gets some value V for V in range, I don't know, let's say 4 through 12, 4 through 11 actually. All right, so there's my set S20. And then a dict comprehension also uses curly braces and also, of course, has to have a for loop. The big difference between a set comprehension and a dict comprehension is that for the dictionary comprehension, you have to have a key and a value for each item in the dictionary. Okay? So here we're saying K colon and then K squared for K going from 0 up to 7. Let me do that one. So D20, dictionary 20, is K colon K squared for K in range 8. Alrighty. Okay, so that gets us through construction using the named functions tuple, list, set, and dict. And we've also seen comprehensions that uses this loop, this for loop notation inside of square brackets for a list, or curly braces for a set, or curly braces with a colon between the key and the value for a dictionary. Next, we're going to take a look at what are called exceptions. Now, an exception, there are literally dozens, probably hundreds of types of exceptions that are named in Python. And when you raise an exception, that is when some kind of error occurs in Python, interactively in your shell, you will be told what that exception is. So if I say 7 divided by 0, I'm going to get told this is a 0 division error. That's one kind of exception. If I say D gets dict 5, well, 5 is not an iterable. And of course, it's not even a pair of values. So I am going to get yelled at here, and I get told that this is a type error. The int object is not iterable. If I try to do a conversion to float of something that's clearly not a float, all right, this string has digits and dots in it, but it's got too many dots. And so the float conversion function doesn't know what to do, and I get yelled at that I have a value error here. Or if I attempt to open some file that doesn't exist, like fn gets open of /foo/asdf for reading text. Well, I don't have any directory on my system named /foo, much less a file in /foo called asdf. So I'm going to get an error here, file not found error. All of these things are examples of exceptions. How do I protect myself from these exceptions? Because if I have an exception like this occur within a program as opposed to within my interactive shell, my program will actually die. Well, the way that you protect yourself from exceptions is to use something called a try block. And at the bottom of the try block, you have an except clause, if you will, to capture and deal with any exceptions that may occur. I'll type one of these in interactively, although this is not particularly common. I'm going to say try to execute val gets 7/0. Okay, nothing has been executed yet because I'm still typing in my my try block. If that thing I'm trying to do fails, I will set up an except clause that gets branched to if the 7 divided by 10 generates an exception, which we know it will. All right, so if the exception occurs, I want to say, all right, in this case, rather than val being undefined, let me just set val to some bogus number, which for our purposes, you know, -1.0 is bogus enough for us. Now, when I hit the enter key a second time here, notice that I did not get any angry red message on my screen, because instead of just manually typing in val gets 7/0 and getting yelled at about a zero division error, when that zero division error got raised here, the Python shell noticed, oh, well, there's an except here. So rather than printing an angry error message and dying, let me instead jump to this except, and we'll let the code do something to handle the exception. In this case, the way the exception was handled is to set val equal to the value -1. Obviously, we can be more sophisticated about what we do to handle errors. Except used this way, where we just have the word except and a colon, catches any possible kind of exception that might occur, including zero division error, type error, value error, file not find error. Any kind of exception that might occur in this try block is going to get handled by this except. It is possible to say except and then give file not found error, a specific kind of exception, so that if that exception appears, you can handle that exception. And then you would have another except for zero division error, and have some code that handles that particular exception. So you can actually have a whole series of specific exceptions following your try. But in our case, we're going to be satisfied to just have the word except, and that will handle any exception that occurs within our try block. Okay, so let's take a look at using this try except mechanism in a program that's asking the user for some input. Users are notorious for doing every conceivable thing wrong. So how do we protect ourselves from users typing bogus stuff as input to our program? Okay, well, the first thing that we're going to do in order to ask the user a question and get some input is to call a function whose name is input. And to the input function, I can give a prompt string. And let me show you how that looks. If I say input, please enter your name. All right, please enter your name is my prompt. What the input function does is to display that prompt to the user and wait for the user to type some input and hit the enter key. When the user types the input and hits the enter key, all of the input, that is the sequence of characters that the user typed, up to but not including the enter key, gets stored as a string referred to by this variable, in this case, answer. Okay, so input has been called. Input has displayed the prompt. Please enter your name. I'm going to say John. When I hit the enter key, input will read JOHN and enter, and it will put JOHN, the string JOHN, into that variable answer. Okay, now let's suppose that instead of asking the user for their name, I say input, please enter your age. And I'm going to type, well, I'll type 49. Let's imagine that I've been 49 for a while here. Okay, now, so this time I typed 4, 9, and enter. The input function always returns a string. And so age here is not a number. Age is a string containing the characters 4 and 9. In order to convert that into a number, I would need to say something like convert the age to a float. And that conversion succeeded because this string of characters 49 can be successfully converted into a float. So now age val is 49.0. But if I had run the same input function here, and instead of typing 49, I said 49. Well, that's fine so far. But if I try to convert this age string to a float, now I do get yelled at. I get an exception. So I'm going to need to ask the user for some input. And then if I need to convert that input string that they typed into an int or a float or some other kind of value, I should do that inside of a try block so that I can deal with formatting problems. All right, let's take a look at a full-blown program that's using this logic. This is a program called userAge, and it is available on Canvas. Actually, let me, I'm going to stop recording for just a minute or two to make sure that it is actually available on Canvas. I'll be right back. Okay, so I have confirmed that userAge is available on Canvas. It's in a directory under the Files area called Lecture Support Files. I'll also post it in the announcement when I announce that this video is available. Let me open this userage.py file, and then I'll have to move the editor window to where we can see it here. So here is the file. Okay, so here's the file, And let's see what's going on here. We are first setting what's called a flag variable, age bad, and we're saying age bad is true. Why are we doing that? Well, the user may make mistakes, and in fact may make mistakes over and over and over and over again. So we're going to have a flag that controls a while loop that is going to ask the user to enter their age over and over and over again until eventually age bad becomes false, we hope. Okay, so age bad is initially true. Also age, which is the variable that we want to store the user's numerical floating point name into, we're going to create and initialize that variable to refer to 0.0. Then we have the while loop, which is doing most of the hard work. While the age is bad, that is, while the user hasn't yet gotten around to typing a valid age, let us try to ask the user to enter their age, get the result back into a string, and then convert the string that the user typed into a float. Now, it's that conversion that is most likely to fail. If we ask the user to enter their age and they type a string of letters, then that conversion to float will fail. And when we have a failure inside of the try block, we will drop into the except part here, and we're going to complain to the user that they typed a bad age format. And then just for redundancy, really, we're going to set the age to -1 because that's, in real life, not a possible age for a person to have. We don't talk about people who haven't been born yet as having negative ages. Okay? All right, so when we hit this exception and the age is -1, well, the age is out of bounds here. So we're going to tell the user what they should have typed, which is an age between 0 and 125. And then we'll go back up, and because age bad is still true, we'll ask the user to try again. Okay, rather than me talking through this mess, let's actually run this and see what happens. So I'm going to run the module, enter your age, and I'm going to type 49. Now that's going to generate an exception, but because we have this except clause in here, my program is not going to crash. I get told that I have a bad age format. I get told to enter a value between 0 and 125. Why that range? Well, again, we don't talk about having somebody have a negative age or even a 0 age. As soon as somebody is born, we talk about them as being, a certain number of seconds or minutes old. We don't talk about somebody as having an age of 0. On the other end, currently, scientists think that just from normal wear and tear during aging, even if you never develop cancer or heart disease or any kind of fatal illness, the people just kind of wear out by around the age of 120. So we're going to require the user to enter an age that's between 0 and 125. If they enter a negative age, or a string as an age, or a value that's greater than 125, we're going to complain and tell them to try again. All right, well, in this case, I typed a string of characters, and I got complained at and told to try again. So let me say, well, now I'm annoyed, so I'm going to say 1234. Now, notice that I didn't get told that that was a bad age format, because the format is perfectly good. The value just doesn't make sense. So I get told again, enter a value between 0 and 125. This time, again, just to be contrary, I'm going to say -12. And no. Enter a value between 0 and 125. So let me say 12.456. Oh, bad age format. I accidentally hit some spaces after the decimal point. So let me say 47.5. And finally, I have typed something that's in a valid format and that's also within the range of acceptable values. So what happens now? Okay, so I'm not going to trigger an exception, and the age is between 0 and 125. So this if part gets triggered if the age is not between 0 and 125. Consequently, I'm going to drop down to the else part and set age bad equal to false. Finally, the user has typed an age that is valid. We're going to say age bad equal false so that the while loop will terminate. And I'll finally get down to this print statement and say age is 47.5. And then I can continue on from there and do whatever I would like to do with my age. Okay, at last. Okay, but we protected ourselves from all kinds of errors, both errors in formatting through the accept mechanism, and also errors in valid ages by using this if test, making sure that the age is between 0 and 125. Okay, so that gets us to the end of handling exceptions. And I've been droning on for over an hour here, so I think we will call it a day here. And I'll pick up with defining and calling functions tomorrow, and then we will get into modules and NumPy. Okay, so I will see you again in the morning.